let me start with inheritance, since we were talking about the classes, objects, and companion objects, primary constructors, auxiliary constructors. When in the same phase, if we continue the OOPS concepts, so let's take up inheritance. And again, if I compare this with Java and why it is like this, it's going to may create a lot of confusion, but let me try to put it as simple as possible. Just try to take them as like a kind of rules or something. Okay. So in general, so what is mean by inheritance? Inheritance, when do we go for inheritance? So we will be using inheritance only when you have some basic features already available, and along with that basic feature, if you want to add your own specialized features to something, instead of making the changes already present in the class, you can write your own class by extending that. So you will get all the features of your parent class into your child class, and you can add your extra features also to your child class. Okay, simple examples like if I declare a class vehicle, okay, and so my class vehicle is, it's my vehicle class, but this is a general vehicle class, general vehicle class. So class car, this is a specific vehicle. So under vehicle, you can represent any vehicle. It could be a car, it could be a motorcycle, it could be plane, it could be a ship. Anything is a vehicle. But all common properties that you want to put at a vehicle level, you will specify there. And anything that can be applicable only for your car object, you will specify them. Okay. So that's we go for. And if you want to take few more examples, let's say I'll take an employee. So all employees will have some set of attributes like ID, name, and department, all these things. And your manager might have, he is also part of employee only, but he will have some extra features. And so employee is also a person. If I want to take a student, even student will also be a person. So I can declare a one parent class which is person, and declare all my common methods in this. Every person will have a name, gender, age, SSN. If I put all the common attributes and all its methods related to this inside a person class itself, then I don't need to rebuild all these attributes again in employee class or manager class or student class. I can just reuse them by extending that person. So you don't even need a name attribute in this, and you don't need to store, you don't need to redeclare them, age, gender, all other a regular person attribute. So this is just to separate out a common features into a generic class, and we call that class in terms of OOPS concepts, that as a parent class or a super class, or Yeah, I think those are the two names that we call by. So parent class or super class, and anything that we write or specific functionality that we implement. So if we give him a department ID and an employee ID, the same person will become employee. And if he also manages a team and he gets some extra bonuses and stuff, he'll become a manager on top of employee. So always there is a hierarchical relation. Wherever you see a hierarchical relation and where you can represent your child class is one of your parent class relationship. If you read this, child class is one of the parent class. If that statement wherever is true, those all places you can use inheritance. Now, employee is a person, that's perfectly fine. Manager is an employee, or manager is a person, both are true. And student is a person. So you can extend student, student class can extend. So you can declare here class student extends person. But is a student an employee? Obviously not. So in that case, so wherever that is not possible, you don't extend that class, because it's not easy to maintain that the generic features in a parent class and specific features in a child class. The more higher you go in this hierarchical order, the more generic attributes you'll find there, and the more the depth you come in this hierarchical order, the specific nature you will find in. Okay, so that's just a brief 2 minutes brief on what is inheritance, when will we go for inheritance. Now coming to it, our Scala inheritance concept.
Shiva, just 1 second. You said the more higher you go in the hierarchy, you get more generic, and the more lower you go in the hierarchy, you get more specific, right?
Specific, okay. Correct.
Yeah. Thank you.
Yep.
Shiva, I have 2 questions. Can you go down?
Yes, Dhanesh. Yep.
So here the class student, we can call it as a person, right? Extends person, and the manager also can extend as a person, right?
Yes. If manager, if I extend this here, let's say, this is my new keyboard. This is a new laptop just there. If I type this class employee extends person, okay, this is true, correct?
Yeah.
Because every employee is a person. Correct. Okay, so class manager extends employee. Okay, if A equal to B, B equal to C, automatically A equal to C.
So this is inheritance inside the inheritance, right?
Yes.
We can keep on inherit. We can keep on inherit the class.
Any level.
Okay.
Yep.
So there are any level maximum we have, like we can go up to 10, 15. I remember some level.
There is no such specific count. I think so, but not more than 256 or so, because it maintains in the stack, the execution of the compilation stack that might have references to one to other. It might not go beyond 256. That's I think max limit as far as I remember. But you can easily go up to very easily. You can go very easily up to 10 to 12 also, and beyond that even no one goes.
Yeah, it is going to be more complex then.
Yep. Yep. More complex.
And regarding the variables using inside the class, right? I have an employee and I have a let's say some other class. Can I create a same variable name, or I should create a different variable name? But those two classes are two different classes. It's not related to each other. Let's say here a manager you extended as an employee, and class student you extended from the person. When I create a variable inside the manager or student, can I create the same variable? Can I create it with the same variable name?
So with a name, gender, age, and SSN again in student.
No, not not in the not from the super class. Let's say something related to person, but those are common.
Yeah, anything that is common, the general practice is put in a super class.
Okay. I'm not asking. Sorry, go ahead.
Okay. So now if you have the common features attributes declared in your super class, you don't need to redeclare them in your subclass. By default, you can access them. So now every student, even if I don't declare, I just declare a branch. Okay, student will have a branch. So even if I just declare one variable in this student, so this student class has 5 variables by default. These are 4 and this one is 5th. You don't need to redeclare them if you want to assign a name to a student, if you want to assign a gender to a student.
Yeah, I get that, Shiva. My question is, let's say manager, we have a field called location. Student, we have a field called location. Okay, that's that's not in this super class, and that's not the person because we have not defined it in person, not person, person or employee. So I can create a same variable inside manager as well as student, right?
Obviously, not at all.
Okay. Okay. And is it mandatory that I have to use all the fields defined it in a person class or the super class?
That's up to your wish. Okay, that's up to your wish. You use it or you don't use it. That's not a problem.
Let's say here name, gender, age, and SSN is there. If I ignore all 4 fields, this should work, right? The student class should work.
Yeah, it works, but if you are not using all the 4, then it doesn't make sense inheriting that. Okay, but it works. Technically, it works.
Okay.
Okay.
Yeah. Thank you.
Yeah. You just have to pass as all empty values for calling this object. That's it.
Okay. Sure. Yeah.
Okay. Anyway, I'm showing the coding part of it. I was just explaining the theory. So coming to the coding standards or the hands-on part of it. So let me take one simple example, just the one that I have here. So I'll take a vehicle class. Okay, vehicle is again same since we were discussing our typical example. By now you might have got used to that. So I'm taking a class vehicle. So this has 2 attributes. So one is ID, vehicle ID, and second one is year of manufacturing. Okay, and so I can now create a class car, and which extends vehicle. Okay, but when, unlike your Java, no, again I don't want to compare that. When you are extending any class, that has a constructor parameters. These are like constructor parameters, right? So the class itself will act as like a constructor, and whatever the class parameters, those are also called as constructor parameters. Okay. So when you have a class declared with parameters also, and if you want to extend that class, so there are some rules that if these fields are vals and you need to override them, override val id int and override val year int and extends vehicle of id comma year. So you have to specify if those fields are, let's say I have this, so if those fields are val types, you have to specify override val id int and override val year int. So you might ask, what if they are not vals? If they are var, and if I just save it at the time of compilation, you can see, so overriding variable id in class vehicle s of type int, value id cannot override immutable variable. Don't expect any detailed explanations on that. That will make confusion. I can explain if you guys need, but in simple terms, I'll give you, if your constructor parameters or class parameters are type vals, then only your Scala will allow you to extend those variables. Okay, and so if you have to declare any field, okay, if you want to declare any field as class for the class instead of ID or something, so and if you want them to be as a var, just declare them inside your class, but not as a constructor or class parameter. But anything, all vals only, try to declare at the class level. And if when you are overriding that, you just have to provide override keyword and val and those variables and extending your parent class with those variables. Okay? And so inside your class, now we discussed val and var in a class parameters. If your class parameters are vals, then only you can extend it. If your class parameters are var, you can't extend it. That rule is now, we have got that rule. Second, inside your class, within this curly braces, okay, you can declare both variables and as well as vals, and you can extend both of them even in your child class. So here in this example, I have declared a model of the vehicle as a variable and brand as constant, and you can extend both of them in your child class as well. So if you want to access that or just to change that model, just you use model equal to Swift. You don't even need to specify the var keyword if it is your superclass variable. But if it is a constant in your superclass, you need to redeclare that with the override keyword. Override val brand. Then it overrides the constant of your superclass. For variable, you don't need to redeclare. You just need to, if you want to override its value, just override it. Otherwise, whatever the value that you have there, that will come to. Now, so I have declared this one variable model equal to C star, val brand equal to Ford, and I have defined the two string methods in these two classes over right there. So ID, I'm printing this, whatever the ID that I receive, and year, this year, and model, brand, this brand. Okay. So why I have two brands here? Okay. So now let me try to show you both val v2 equal to new vehicle s of 10, 2016, and println of, just let me print that. Okay. So when you created an object of this vehicle S, so you passed the 10 and 2016 as a constructor parameter, right? So that got printed ID as 10, year as 2016, model as Fiesta, and as Ford. Okay, and 2 times I printed the same, this dot brand or just brand. Now, when I created the car S object 20 and 2015, and this values by default, so this constructor should get executed, and this is in turn extending this vehicle of ID year, and this will call this constructor, and that way the ID gets set into 20 and year gets set into 2015. Now, at the time of printing, when I'm printing this println of v1, so this toString method should get executed. But inside this, what I'm trying to do, I'm calling the super class toString. Before printing this class toString method, I'm calling this class. So inside this your super class, your ID is 20 when you are creating the second object, and year is 2015, and model is this dot model is a script. Because the object v1, so even though you're calling super dot the toString, so this dot model, so when you called this, it has overridden, because in model this is the script, and even though this is calling this and it's printing this, even if I stop all these things, just okay, you can see that in my subclass CarS, I'm simply calling the super dot toString, but still whatever the values that you have overridden by the time this class got declared, so your model is still pointing to your Swift, and brand is Maruti, and again second brand is also the brand variable is got overridden, it has a Maruti, and finally it's just printed in subclass. This way, you can override the constants declared as a class parameter, and you can override the variables, you can override the constant, and you are already overriding the methods. If you want to override the method of a parent class, just override def and your method name, your parent class method name, and provide your new implementation. Okay. Any questions on this? So if you override the same method that is present in the parent class, and if you provide a different implementation in your child class, that is called as method overriding, which is the dynamic polymorphism part. As per the OOPS concept, we call that as method overriding as a dynamic polymorphism type. What is mean by polymorphism? With the same name, doing two different functions. If I call this println of v2, this is calling this method and printing these values. And if I call the same this method from inside this class, and all the values getting overwritten. With the same name, different behaviors. That's called polymorphism. Okay. Any questions around this?
Hey Shiva.
Yes, Raj.
Now let's take an example. If I want to pass any parameter in the constructor of car S, then how can we pass that parameter here?
How can you pass that parameter? You write your auxiliary constructor.
Oh, okay.
With extra parameters. Right?
Yeah, that's fine. I just thought maybe we can pass as our primary constructor.
Yeah, you can. You try giving them just a val or var something. What is miles? See, you just pass them how many miles that driven. Right? It accepted that.
Oh, okay.
Either you do this way or you write your constructor.
So like if you want to refer any method from the parent, then you have to use that super keyword, same as the Java.
Same as Java. Yep. Super okay. And this keyword same as Java.
Okay. Thanks, Siva.
Yep. And override is also for the same purpose. In Java, you use annotation. Here, you explicitly specify that override keyword.
Yeah, I got that one. Thanks, Siva.
Yep. Okay. Dharmesh, Snehali.
Yeah, I got it.
Shiva, so far.
So far, it's smooth, right?
Yeah, I'm just a little bit confused with the override part, but I think I'll read on it and then I'll be fine because I got it, but I don't think I've understood it pretty well. So possibly I'll have to read something on it. Or we can take it after the class.
So override keyword, you use it for in case of constant. You again specify that override keyword if you want to override a constant. And if it is a method, always you have to specify override if you want to write the same method in your child class.
Okay.
Okay.
Shiva,
Yes, Dharmesh.
this ID and year, right? I can pass the empty class, create empty class with vehicle S, right? Why you create ID, only ID and year? I can create it inside the class and then I can use it, right?
You can do that. Not at all a problem. You can
So
do that.
In that case, car S is going to be empty, right?
Yes. Here, why empty? Well, I can declare my var miles, right?
Yeah, you can. Yeah, definitely, you can create it. You can define it. But in this
And
case,
this,
yep.
this list will be empty. That's it.
Okay, and inside, like how you defined the brand, the same way I have to override ID.
All the fields.
Okay.
Yep. ID and year. Correct.
Okay. All right.
Okay.
Yeah, I got it. Thank you.
Okay. Yeah.
Shiva?
So, yeah.
The last question, is there any order specific in CarS constructor? Let's take an example. If you put miles in front and all that stuff, then is it okay?
What is cat specific?
Let's take an example. Here is a ID integer in the CarS constructor, ID integer and a year integer, right? So let's take an example. If you keep at the last and you keep the miles very first parameter, then is it okay? Because in the Java, you know that, right?
No, it's not okay.
Okay, then it's the same as the Java, right? Very first, you have to use the super.
Yep.
Okay.
Yep. Okay. Okay. So now, yeah. So let me. So this is the only Scala part of inheritance I talked about. So just to summarize, same thing. We can override only vals, but not vars in class constructor parameters that we have seen. And if there are any vars in your parent class, you can directly override them or extend them without any override or var keyword. But for vals, that is mandate. Okay. And variables do not need redeclaration, same stuff. And the scope of variables will be overridden in the parent class. That means whatever the variables that you are setting from inside your subclass, that values will get reflected in your parent class as well. That's why when we called the super dot string also, it printed all your subclass values only here as well, but not the Fiesta and Ford. Okay, and those points only I have listed down there. Can go through them.
That's applicable for only the subclass, right? And whatever there in the main class, if I execute something through using main class, it will maybe report whatever there in the main class.
Yes, correct. That's why we saw that V2 just with the main class. So that printed the Fiesta and Ford.
Okay.